All right, welcome back, everyone. It's great to have you back with us for another deep dive. Remember last time, we were talking about the universe battery, that essay by Lev Neymotin. It was like the idea that all the energy we use, everything, is actually just leftover juice from the Big Bang.
Yeah, it was pretty mind-blowing. I mean, to think that we're still running on energy from that initial explosion billions of years later, it really puts things into perspective.
Right. And you know what's even cooler? We got this material from a listener. It takes that whole universe battery idea and it kind of like kicks it up a notch. So get ready, because today we're going full on sci-fi. We're diving into some super futuristic tech that could, maybe, actually tap into that cosmic energy source.
I think they're called Quantum Oscillation Nodes.
Quantum Oscillation Nodes, QONs. I mean, even the name sounds like something out of a sci-fi movie.
Okay.
But the idea here is like you create these tiny little vibrations in space-time itself. And those vibrations can somehow pull energy right out of those dark energy fields everyone's talking about.
And they use quantum entanglement to keep the whole thing stable.
Yeah, quantum entanglement. I mean, come on. How crazy is that?
It's definitely a pretty wild concept, but the source material goes into some detail about how it might actually work. Basically, you would have these super advanced materials engineered at like the nanoscale, and they could actually interact with these quantum fields that are, all around us all the time.
Okay, wait. So we're talking about building these tiny machines that can mess with the fabric of reality itself. That's pretty intense.
Yeah, it's pretty out there. So the idea is these nanomachines, they apply these extremely precise forces. And those forces can pinch dark energy out of the vacuum of space.
Pinch dark energy. I'm not even sure what that means, but it sounds pretty cool.
Right. And that's where the entanglement comes in. It basically keeps those pinches from just like disappearing. It stabilizes them. And then that dark energy that they've, pinched out of space gets converted into like usable electricity.
So it's like squeezing energy out of thin air.
The source material actually uses a different analogy. It says it's more like harvesting the ripples of space-time and then amplifying them into a tsunami of energy.
A tsunami of energy. Whoa. Okay, now I'm really getting excited. I mean, if we could really do this, the possibilities are just like endless.
Think about it. Infinite power grids. You'd never have to recharge anything ever again.
Or like tiny little power sources that could run entire cities. Space travel without any fuel, just using the energy of the universe itself.
It's pretty mind-blowing stuff.
Yeah. I'm trying to picture it. Like instead of a DAS gauge in my car, I'd have a space-time connectivity meter. And if it starts running low, I'm like, oh, got to plug into the universe for a refill.
I like that. But we do need to remember that this is all, very theoretical. We're dealing with some pretty advanced physics here.
Right. It's definitely still in the what-if stage. It's like we're just getting a glimpse of what might be possible, but we're not quite there yet. But hey, who knows what the future holds.
Okay, so let's maybe come back down to Earth for a minute. We were talking about all these amazing possibilities, but before we get too carried away, we should probably talk about, how we actually build these things.
Yeah, like I get the basic idea, but actually making it work, that seems like a whole other level of complicated.
Right. Like, remember we were talking about those materials, the ones that would interact with those quantum fields? We're not talking about, like, just tweaking some stuff we already have. We're talking about inventing totally new materials.
Yeah.
Stuff that can do things we can barely even imagine.
Like what? What kind of stuff would we even need?
Well, they'd need to be able to interact with dark energy, and that's something we, barely even understand. We're talking about messing with, quantum fluctuations, maybe even at the Planck scale, which is
Planck scale. That sounds familiar, but remind me. What's that again?
Okay, so imagine you take the entire universe, right? Everything we can see, and you shrink it down to the size of, an atom. And then you take that atom and shrink it down to the size of a proton. The Planck scale is even smaller than that.
So we're talking about building these things out of, the smallest possible pieces of reality.
Pretty much, yeah. It's the absolute limit of smallness. And we'd have to, perfectly control everything at that level.
Okay. That's pretty challenging, to say the least.
Yeah. And that's just the materials. Then you have to figure out how to actually extract the energy, right?
Yeah.
And the source material talks about these precise oscillatory forces. But how do you even create a force like that at that scale? It's like trying to, build a house of cards out of individual atoms.
And how do you even measure what's happening at that level? It's like trying to watch a single grain of sand move on a beach from, space.
Yeah, exactly. I mean, we're talking about technology that is, way beyond anything we have right now. We need to be able to manipulate individual atoms, maybe even subatomic particles. And then there's the whole entanglement thing. Not only do you have to control it, but you have to maintain it over, like, huge distances.
This is starting to sound like a pretty long shot.
Right. But, impossible is a word that a lot of times just means we haven't figured it out yet. Think about it. 100 years ago, splitting the atom or going to the moon would have sounded just as crazy.
That's true. But those were still things that we, basically understood. The physics was there, even if the engineering was really hard.
Yeah.
This just feels like we're missing, like, huge pieces of the puzzle.
Right. It's definitely way beyond our current understanding. But that's part of what makes it so interesting. We're talking about, like, the edge of what we know, the very limits of what we thought was possible.
Yeah. It's definitely thought-provoking. And even if we never actually, build these QN things, just thinking about them could lead to some amazing discoveries.
Right. It's like exploring uncharted territory. You might not get where you thought you were going, but you're bound to find some pretty amazing things along the way.
So even if we never actually get, infinite energy, just trying to get there could lead to some incredible new technologies and scientific breakthroughs.
Exactly. Who knows what we might find?
This has been quite a mind-bending conversation. I think we've covered, like, the how pretty well. But what about the why? Even if we could do all this, even if we could overcome all these challenges, why bother? What's the point?
That's a good question. It's definitely worth thinking about, like, what would it even mean to have access to, basically unlimited energy? How would that change things?
So we're basically saying that building these QNNs would be, like, insanely difficult. But let's say, for argument's sake, that we actually did it. What would be the point? Like, why even bother going through all that trouble?
Well, think about what it would mean to have access to, basically unlimited energy. No more fighting over resources, no more worrying about running out of fuel, no more wars over oil.
Are we talking about, like, a utopia here? A perfect world powered by space-time? Because that sounds pretty good to me.
Well, maybe not a utopia, but it would definitely be a huge change. I mean, think about it. For, like, all of human history, energy has been this scarce thing, and we've fought over it constantly. What if we could just, like, get rid of that problem entirely?
Yeah. It's hard to imagine what that would even look like. A world without energy scarcity.
Right. The source material talks about how it could change everything, like society, politics. Imagine a world where everyone has all the energy they need. We could focus on, like, actually solving problems. Poverty, disease, climate change.
It would be like hitting the reset button on civilization. We'd have to completely rethink everything.
Exactly. And it's not just about our planet. Think about space travel. We could go anywhere, do anything. Build giant space stations, colonies on other planets. We might even figure out how to travel faster than light.
Okay, now I'm really getting excited.
Yeah.
But let's be realistic for a second. Even if we never actually get to this point, even if QAnons stay in the realm of science fiction, isn't it still worth, like, thinking about, dreaming about?
Oh, absolutely. I mean, that's how progress happens, right? We imagine things, we push the boundaries of what we think is possible, and sometimes we actually achieve those things.
Like aiming for the stars. Even if you only reach the moon, you've still done something incredible, right?
Exactly. And you never know what you might discover along the way. That's the whole point of science, isn't it? Exploring the unknown, trying to understand the universe and our place in it.
So even if these QNNs never actually become a reality, just the act of exploring these ideas, it kind of, like, expands our minds, right? Makes us think bigger, bolder.
I think so, yeah. And who knows, maybe someday someone will look back at us and be like, wow, those guys back in 2025, they had no idea what was coming.
Well, I think that about wraps it up for this deep dive. Thanks again for bringing this in. It was definitely a fun one. This is what we love to do, exploring the edges of what's possible, even if it seems, totally impossible right now.
And thank you all for listening. Keep those minds curious, keep asking those big questions, and remember, there's a whole universe of possibilities out there just waiting to be discovered.
Keep diving deeper, and we'll see you next time.